All right, so here we have a box of books. They give us the weight of the box. So see right here, it says 300 newtons. Is that the mass of the box? It is not. That's a very common mistake to make early on in physics. You plug in the given weight of the object as if it were the mass. This is not the mass. How can we figure out the mass of this object if we're given the weight? What's the equation for the weight of an object? Mass times gravity. Weight is also known as force of gravity, right? Force of gravity or weight, the way you solve for it, it's equal to mass times gravity. So the mass of this object is going to be the weight divided by gravity. So let's just use gravity as 10. Is everybody okay with that? We'll just use gravity as 10, round the 9.8 to 10. It's easier for doing calculations. So the weight, the given weight is 300 newtons. Let's just say gravity is 10 meter per second squared. This comes out as 30 kilograms. Now, where did we get kilograms from? Newton over meter per second squared. I just want to remind everybody, a newton is actually a larger unit. Newton is shortcut for kilogram meter per second squared. So you see the meter per second squared cancels and you get kilograms. So the mass of this object is 30 kilograms if we use gravity as 10. Okay, the other thing I want to talk about is this above the horizontal, below the horizontal. So here we have a box of books, and then right here it says it's shoved across the floor by a force of 400 newtons exerted downward at an angle of 35 degrees. Okay, so what's going on here? I'm going to show you. If the force is being exerted below the horizontal, that tells us it's directed this way. Where this dotted line right here, dot, 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 this dotted line represents what? The horizontal. So then it's 35.2 degrees. Now what if they would have told us the force was above the horizontal? If they told us the force was directed above the horizontal, what would have that looked like? That would have been like this, you know, directed this way. Does that make sense? So the horizontal can be put anywhere. 97% of the time, angles in physics are given off of the horizontal, and they want you to give your answers. When you're doing a calculation, they want you to give the answers off of the horizontal, okay? Now, when you're doing problems from the College Board, you'll notice that just to be tricky, they'll give you, in the given, they'll sometimes give you angles off the vertical. But why are they doing that? Just to be tricky, you know, just to make you think. But the convention is angles are off the horizontal. All right, so what I want you guys to do, I'm going to give you 6 or 7 minutes, and I want you to do the 3 steps. Step 1, draw a free body diagram, which I've already started for you here. Step 2, sum the forces in the x and y direction. And then step 3, solve the problem. And let me say one other thing here. Look, the question says this: how long does it take to move the box 4 meters starting from rest? What type of problem does that sound like? How much time does it take for the box to move 4 meters if it starts from rest? That sounds like a kinematic problem. Do you want to know why it sounds like a kinematic problem? Because it is a kinematic problem. So the way you're going to solve this question is you're going to use this kinematic. X equals 1/2 at squared plus v initial t. What do they tell us about the initial velocity? Right here. Starting from rest, so that means v initial is 0. So what we have is this, right? Solve that for time. Time is going to be equal to 2x over a square rooted. But what do we need to get? In order to solve for the time, the x right here is 4 meters. We're looking for the time. What do we need to get? The acceleration. Now, how are we going to get the acceleration of the box? From analyzing the free body diagram by analyzing the forces. You're going to figure out what the acceleration of the box is based upon what you know about forces. Does that make sense? And then the problem ends with a kinematic. Once you figured out the acceleration, it's going to be a kinematic problem. Now, is finding the acceleration going to be a one-step calculation? Nope. It's going to be 3 steps. So I'm going to tell you this. First thing you're going to have to do in this problem, first thing, after you sum the forces and all that, you have to find the normal force. Second thing, you're going to have to find the friction, which happens to be kinetic friction. The third thing you're going to do is solve for the acceleration, and then once you have the acceleration, you can find the time. Okay? All right, so take 6 minutes. Diagram looks like this. You always start with the free body diagram. So the forces acting on this object, this box of books. Does the box of books have a weight? Yes. And weight is always directed straight down. Okay? Now sometimes you're going to see this force labeled W for weight. Other times you're going to see this force labeled as F sub G, which is force of gravity. Weight and force of gravity are the same thing. Okay? But most commonly you're going to see this labeled mg because that's the equation for weight or force of gravity. Good? Okay, is this box on a surface? Yeah, so if the box is on a surface, the surface is exerting an upward force that we call the normal force, and we call it normal force because normal means perpendicular to. The normal force will always be perpendicular to the surface. So for example, if this box were on a hill, which way would the normal force be? Like that. The normal force would be perpendicular to the hill. Okay, what other force? Well, we have the 400 Newton force that's exerted below the horizontal. So that's like this. This box is being pushed down and over simultaneously. So we have this 400 Newton force, dot, 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 dot. Hey, what does that dot, dot, dot show? Horizontal. The horizontal. And then show your angle. This is 35.2 degrees below the horizontal like that. So somebody's like, you know, imagine this pushing down and over simultaneously. So we have a vertical and horizontal force within that 400 Newton force. Okay? And then lastly, we have friction. The problem mentions friction. What do we know about friction? It's always opposite motion and parallel to the surface. So it's a kinetic friction. Did I talk about the 2 types of friction in here? Yeah. There's kinetic friction and static friction. The equation is the same. So what would kinetic friction be? It'd be mu kinetic times normal force. All right? This is the free body diagram. So let's move on to the summing of the forces. So what we do next is we sum forces X and we sum forces Y, like that. Now, looking at the X direction here, how many forces are in the X direction? 2. But you know what? I want to make this more clear. What I want to do is show the components of this 400 Newton force. Is the 400 Newton force perfectly X? No. Is it perfectly Y? No. It's both. Yeah, then just watch this video tonight. Okay? Okay, so what I'm going to do, I'm going to show the components of this 400 Newton force. So this represents X component of the 400. This represents Y component of the 400. So what I did here, guys, look at this red arrow represents the X component of the 400. This red arrow represents the Y component of the 400 Newton force. How do you find the X and the Y components? By using trig, sine and cosine. Now, let's see, sign conventions. Before we go any further, I'm just going to put the sign convention here just so we're all super clear. To the right is plus, to the left is minus, up plus, down minus. Okay, that's our sign convention. Now, the 2 forces in the X direction are this guy and this guy. Those are the only 2 forces in the X, right? So when you sum, it's going to look like this. You're going to go cosine 35.2 degrees times 400 newtons, right? Now what's cosine 35 times 400? That is this guy. That's the x component of the 400. All right, minus friction. Friction kinetic. It's kinetic friction here. Now, yo.
Wait, I'm sorry, what was the force going to the left?
This one, oh, this guy right here, Fx. That's, yes, the x component of the 400.
To the left?
Oh, no, the force to the left is friction. That's kinetic friction.
Oh, it's called, oh, never mind,
Okay, so what did I just do right here? I summed the forces in the x direction. What will the sum of the forces always equal? ma, where that's an x acceleration. We just wrote an equation that we're going to use to solve the problem. Okay, now let's go to the y direction. In the y direction, how many forces do we have? 1, 2, 3. There are 3 vertical forces. How many of those 3 would we consider to be positive? Just one. The normal force points up, so it's positive. mg points down, so it's negative. And then this Fy points down, so it's negative. All right, so when you sum the forces in the y, in fact, I need a little more room here. I'm going to scoot this over. So when we sum the forces in the y, here's what it looks like. You're going to have normal force up, mg down, so make it negative, and then minus sine 35.2 degrees 400. So what's that? The sine 35.2 times 400 is what? Fy. Why did I make it negative? Because it's down. Okay, so I have all 3 forces from the vertical. What did I just do right here? I summed the forces. What will the sum of the forces always be equal to? ma, where that's a y acceleration. Okay? Now, will this box of books accelerate in the vertical? Is it going to like launch and accelerate into the sky? No. Is the earth going to open up and it accelerates into the ground? No. So what can we do to the vertical acceleration? Set the y acceleration equal to 0. So just be aware it's technically equal to ma. It's just that the a went to 0. Okay? At this point in the problem, the hard part's done. The remainder of this problem is algebra. So I'm going to walk you through it. The first thing you're going to calculate from this point, you're going to calculate the normal force. Now, how are you going to get the normal force? From this equation right here. What's the only thing missing in this equation? Normal force. So solve it for normal force. You should come out with 530.57. Okay. After you find the normal force, you're going to solve for friction. What is this? What is the kinetic friction? Now, how can you get the kinetic friction? Well, no, you're not going to get it from up here because we don't have acceleration yet, right? You're not going to get it from this equation because we don't have the acceleration. The way you're going to get friction is from this equation. What's the equation for friction? Coefficient times, not the natural force, normal force. Okay? So the 0.57 is the mu, right? Mu equals 0.57, okay? So and we now have the normal force, so you solve for the friction. The friction comes out as 302.43. Then third thing, now that we have friction, look at this equation. What can we get now? The acceleration. So from this x equation up here, you can now solve for the acceleration, which is an x acceleration. The acceleration comes out as 0.81. And then lastly, you can answer the question, which is how long would it take this box to slide 4 meters. You plug into a kinematic, and you get t equal to about 3.1 seconds. So the rest of it, after you have the forces summed, you're back into like 8th, 9th grade algebra.